Hey everyone, let's look at creating procedural landscapes using Bezier curves. Now, Bezier curves are just rules on how to interpolate between different points. For terrain generation, we can use them to define custom smooth looking landscape shapes. Here, we'll use Bezier curves on each edge of our terrain, and then use the different curves to interpolate and determine points for the vertices inside of our terrain to get different heights. In a previous video, we created a procedural mesh to generate a plane. In this video, we'll expand from that plane to create terrain based on Bezier curves. Here, I can duplicate this procedural plane from the previous project. Duplicate it, we'll call this BP Bezier terrain. Now, if we open that up, this includes our previous functionality. In here, we determine vertices in the UVs, determine the triangles, calculate tangents, create the mesh, and then set its material. And we can drag this Bezier terrain out into our world and hit play. Currently, we have a very spiky terrain. Let's increase this size to 2000, 2000. Here's the current terrain using our previous plane and terrain generation. Now let's change this so that we have Bezier curves along the edges, and we can interpolate between those different Bezier curves to determine the heights of our terrain itself. So in the Bezier terrain, we'll want to create a new function in here. And before we determine the vertices and UVs, we'll want to determine the Bezier curves themselves. So here we'll create a new function and call it determine Bezier curves. Now in this function, we'll need to create 4 Bezier curves, one for each edge. We'll have 2 X direction curves and 2 Y direction curves. So let's first look at how to create a Bezier curve using some built-in functionality in Unreal. So what we can use is a spline. In here they have a spline component, and we can add a spline component to our object here. Now if you're adding many spline components, so if you're adding thousands of them and making a very large terrain, here you'd want to use a custom way of generating your Bezier curves instead of generating all these components, as these will add up in terms of computational workload for your blueprints. But for now, for just generating 4, I'll generate it this way, and maybe in a future video we could come back and look at how to optimize this. So once we have our spline component, then we can go ahead and hit clear spline points. Occasionally they will start with 2 points already set up, so here we can just make sure that we start with none. And I'll enable manual attachment so we can tell the spline component where to attach to. Some other settings we can set for our spline would be the closed loop. So set closed loop. So here we don't want our loop to be closed. We just want a line rather than a circle. Now that we have this set up for our Bezier curve, we can start adding the points. So here we can say add point. So we'll connect this up. So that'll add our first point. That'll be our starting point for our curve. And then we can add a tangent or set a tangent at the spline point. And we'll use that for the same, set the tangent for that first spline point. And then we could go ahead and copy and paste those two. And we'll set our second point and its tangent. So overall, we'll be setting 4 positions. 2 are for the points and 2 are for the tangents. Now we don't need to update our spline every time we're editing it. So let's just go ahead and remove these and only update it on the last element here. And yeah, we can uncheck that for clear spline points. So in here for our first point, let's First, think of this spline as a y spline on our y direction. So first we'll look at this and say when this is y equals 0, we'll change. So this will be on our y equals 0 axis. And our x will change over time. So in here we need to add our targets. And then we go ahead and add our points. So this is our first point here. We can drag off of the point and make a spline point. Now here we're giving some options. Let's leave this collapsed for now. So we need to set our input key and a position. So the input key will be the value along the curve associated with this position. You could think of this as a keyframe. So this will be our first point, so we'll have a key of 0, and the position will be our first point in our Bezier curve. So this, since it's our y equals 0, we'll say this connects to our point 0, 0, 0 in our overall terrain. And compile and save this. Let's look at our next point. So this is our tangent at this spline point. So here we'll just call it point index 0 is our first one. Let's do everything in our world space. And for our in tangent, here we can make a vector. And this will be our tangent point for this first point. So since we're going along our y direction here, let's keep our y in our tangent the same, and let's just edit our x and z. So for now, let's just hard set these, and then we can come back to randomly set them based on the overall scale of our mesh. So right now, let's just set each as 1,000, and we can see what that looks like and adjust from there. Now for our next point, let's make a spline point. This one will be our final point, so it'll be at key 1. And the position will be at the end point along this curve. So what we can do is split our struct here for our position. So our x position will be down the y curve. So the last point will be at the farthest x position, which will be our x scale, as that'll be the farthest distance down that we go down this y curve. And again, our y will be 0 since this is our y equals 0 curve. And then our position z, we can come back to that later. Let's leave it at 0. But this can be the height, and we can edit the height of these points. But for now, let's have the endpoints be at height 0. And now for this last tangent point, this will be for our point index 1, as this will be our second point in the curve. And we'll make this tangent, make vector. And before I forget, let's set it to world space. Now here, let's go ahead and set the same exact values as our last tangent. And then we can see what that looks like at when we generate the terrain. And then we could go ahead and edit that based on what we think it looks like and what we want. So for now, we'll just set it as 1000, 0, 1000. So that'll be our first curve. This is for y equals 0. Now we'll need some way of storing this curve so we don't lose track of it. Let's go ahead and make a new local variable. Let's call this y curves. And this can be of type spline component. You can drag this here at the end, or a set at the end. And we'll actually want to make this an array. So this will have two curves in it, our two different y curves. Yes, I do want to get this y, get curves, and we'll add a new one. We can add in our spline curve that we just made. There we go. So this will be for our y equals 0 case. Let's go ahead and just add a sequence here at the beginning. That way we can generate all 4 curves separately, just in a sequence. And then later, you could go back and refactor each of these sections in here to generate the splines more efficiently or within a function. But for now, let's just add in a sequence. And we'll copy and paste this y equals 0 case. Put it below. This will be our, connect that up. This will be our y equals y max. We'll call it max y. So this will be at the other end of the terrain from our y equals 0. This will be our maximum y direction. Now in here, we need to set our points a bit differently. Let's break this first point. So our first point is still at x is 0, but we're at our farthest y point. So we'll drag in our y scale. And again, leave our position at 0. We'll leave the tangents the same, so we can skip that. Now for the second point, instead of y 0, we'll have our y scale and leave our tangent the same, and then add our curve at the end. So there we go, we have our second one already. Let's add 2 more pins on our sequence. So these next 2 will be our x curves. I'll go ahead and copy this y equals 0 case, paste it down, and we'll call this x equals 0. Connect that to our sequence. Now here we'll be setting our positions and tangents so that we're on an x curve instead of a y direction curve. So let's have our first x curve still be at 0, 0, 0. This will be our origin. And this will be the same as our y0 curve. So that way those 2 curves can meet up in that corner. Now for our tangent for that first x position, let's set our x to 0 and our y up to 1000. And then once we generate the terrain, we can look at modifying these again to generate different sorts of shapes in our terrain. Now our second point, we don't have our x scale. Here our x is 0 since we're along our x equals 0 curve. But here we're at the very end of our y direction. So we'll be at our maximum y of our y scale. So we'll start at 0, 0, 0 and go to 0 max y 0. And for the second tangent, we'll set our x to 0 and our y to 1000. That's our first x curve. Let's generate a second x curve. Connect it to the sequence. Now this one will be x. This is max x. We can break our position. Here, our x value will be our maximum x. And our starting position, we'll set it as 0 for y. Keep the tangent the same. Now here for our second point, we'll drag in our x scale since we're at maximum x. And now we're at maximum y. So we're in the farthest corner from the origin. And keep our tangent the same. There we go. So let's compile and save that. Now, if we test this and hit play, we'll be able to see these 4 curves that we've created in the world, but they won't be affecting our terrain currently. And actually, before we do that, we have these different y curves that we're adding. On these bottom 2, let's change this to x curves. So let's create a new local variable, x curves. And I misspelled y, so let's rename that one. And we can add these last 2 curves to our x curves array. Now let's hit play and see what this looks like. I'll jump out. And we should be able to see these Bezier curves in the world. But we're not currently seeing them, so let's see why. So I think that's not working. We didn't actually create, in our event graph, we didn't actually bring out our determined Bezier curves node. Let's connect that to our begin play so we actually create those. And when you go into the map, if I hit play and click on our terrain, There we go. So we could see the curves being generated. So we'll want now to set our terrain heights to these curves. So if we go back to this Bezier terrain blueprint, we want some way of getting our Bezier curves from our determine Bezier curves node or function into our determine vertices function. So let's go ahead and create an output in our Bezier curves function. This will be our array of Bezier curves. So first we'll say our y Bezier curves and then our x Bezier curves. This is of type spline component. Let's call this y curves. And we'll add a second one, and this will be our x curves. In our determined vertices, let's add some inputs. And this should be the same type of spline component. And we'll just plug in our y curves and our x curves. Now we can connect those up. In our Bezier curves, now we'll need to set up our return node. Connect that here and return out these local variables that we've been using. However, I named these the same thing. So let me change the names of our local variables to local y curves and local x curves. Oh, our outputs aren't arrays. I need to set those to arrays. Now I can plug those in. And then if we go back to the event graph, I'll need to make the inputs on this determined vertices also arrays. There we go. So now we'll be able to get our Bezier curves after we determine them into our determined vertices function here. Now currently from the just generate plane with some varying heights, which is what this is doing for our vertices, we are looping through all of our x's and y's to set our vertices along those x's and y's with some randomized height value. Let me delete this randomized height value. Now if we hit play, we'll see we just have a flat plane and our Bezier curves on the edges. Now let's go ahead and try to get our plane to match these curves themselves. So I'm going to delete our current x and y locations. Let's just get all of our position information from these curves themselves. So let's see, what did we call these? Y curves and x curves. Over here for our, when we determine our local vertices, let's get our y curves and our x curves. Now first, let's look at our y curves. We'll have two of them. So let's get our first one and get our second one here. We want some way of combining these two curves. So we'll combine our two y curves along that goes from our y is 0 to our maximum y value. So to do this, we could get our position along the curve itself. So we'll get our location at time. So our time is how far down the curve we've gone. So on our y equals 0 curve, our time will be our x value. So how far we go down that curve is our x value. But this is a value from 0 to 1. So instead of our x value, let's use our normalized x, which is a value from 0 to 1. And again, we'll use our coordinate space as world. We'll try to use world for all of them. Let me copy and paste this. Get location at time node. So we're getting our location down these curves for our y equals 0 and our maximum y. Now here we could combine these two locations kind of in any way we wanted. For now, let's go ahead and just add them and average them, and then we'll look at creating a better way of combining them. So for now, let's add them and then divide by 2. And then this will be our average position between our two y curves. And let's do the same for our x. So I'll copy all of this and paste it back, and we'll connect up our x curves into our get nodes. And instead of our normalized x being our time, it'll be our normalized y being our time. And we'll add those in, just take the average. Now also let's just add these positions between our x curves and y curves, and we'll average those out as well. Can bring this up. I'll break it so we can separately connect our x, y, and z, but you could just connect in the full vector if you want. Now let's play and see what we're doing here. So it looks like we're creating the correct shape for our terrain, but we're a bit offset from our starting point. That's because since we're adding the two vectors together from our x's and our y's, we are creating an overall larger vector value, so we're offsetting it in the positive x and y directions. So we're creating our correct shape, it looks like, but we'll have to see how we can combine these in a different way to get them in the correct location. But it's looking like our shape is good. Let's go ahead and up our resolution. Let's up this to 50 vertices on each direction, and we could see the curve being smoother. There we go. Nice. Let's return back to our Bezier terrain. So here, instead of doing these averages, one thing we could do to help remove that offset would be to also average these two together. So this should be in the correct position now. But we are scaling it down. So we're at the correct position, but we're scaling the mesh down by a size of 2. So we still need a different way of combining these different Bezier curves together. So we'll go back. In here, let's look at our y curves first. We move this away and comment it, combining the curves together. So let's look at our y's. Let's delete what we currently have. Now what we could do to combine our two different y curves, let's look at a way to combine them such that when our y equals 0, we're only using our y curve, and when y is our max, we're only using our y max curve. And that way we don't need to scale it in any way, since we're only using that one curve and not the other. And then for intermediate values, we can add the position from those curves based on a weighting of those curves. So if we're directly in the middle, we'll use 0.5 of this curve and 0.5 of this curve. If we're at a value of y equals 0, then we'll use 100% of this curve and 0% of this curve. So to do this, let's go ahead and we'll drag out our position here, and we'll want to multiply this by some weight value and then add it to our y max curve, which is also multiplied by some weight and then added together. So to determine our weightings, we can use our normalized y. So this is how much we are on our y-axis. So for our maximum y curve, we can go ahead and just plug our normalized y directly into it. So here, if our y is at a value of 1, that's our max y, we multiply our curve by a value of 1. So 1 is our weighting, 100%. And if we're not on this maximum y curve, then our normalized y will be 0. So we'll multiply our position by 0. So our weighting is 0 in that case. And then we can also use this normalized y for our weighting up here, but we'll also add in a minus node. And this will end up being a 1 minus. So we'll do the opposite. Let me convert this to a float. There we go. So for this first curve, this is when our y equals 0. We want this to have 100% effect, 100% of our weighting on this curve when y equals 0. So let's see. When our normalized y equals 0, we have 1 minus 0 is 1. So our weighting overall is 100%. And when our normalized y is 1, we'll have 1 minus 1 is 0. So then we'll have 0% of this curve. So in this way, we're kind of like interpolating between these two different y curves along our y direction. And we can do that for our x's as well. So I'll delete what we currently had, our averaging, and go to this normalization weighting based method for our two x curves. Connect those in, but instead of normalized y, we'll want to drag in our normalized x. So there we go, we're normalizing on our x curves. And then we can add these two together and average between our x's and our y's. And now let's see what that looks like in our map. And there we go. We're currently creating our train at the correct location. And you could see it's not following the curves exactly. And that's because we are averaging between our x and y curves. So due to the averaging, we're like smoothing out the terrain along each curve based on the neighboring curves. So our y curve here will have some influence on our x curve here and drag down the height of it. But it looks like overall we are generating our terrain. Well, let's stop. And we can go back and look at now, how do we modify this terrain to kind of like procedurally generate different shapes for this Bezier curve-based terrain. Go back to our determined Bezier curves. So in here, we'll determine how these Bezier curves are actually created. We also have currently four copy and pastes of the same code for adding in splines, but with just different x and y values for each one. So you could go ahead and create a function out of this and modify the x and y's as inputs to that function. But for this example, I'll just leave it all kind of copy and pasted here just for clarity to show what we're doing. And then you could go ahead and refactor it later to condense it down into functions and make it cleaner and more scalable for your project. But let's zoom in. Let's look at this first y equals 0 curve. Now here we want our position to be 0, 0, 0. But let's go ahead and adjust our height of our first starting point. So let me break this struct pin so we can choose a random height for our starting pin. And let's just make a random float in range. Let's say maybe minus 500 to 500. Now let's look at our z position that corresponds to the same point. So this was at our 0, 0, 0. We go down to our x equals 0, we'll also have the same point. Let's split this. And we can add in that same range. Now this won't be the same height, but we will be modifying this height between this x and y curves at our origin point. But then remember, we're also then averaging between the two. So let's try it out here in the world. Let's hit play. Now it looks pretty similar, but let's jump out and look at our curves. So you can see here our two curves have offset heights from our 0 spot, and then we're taking the average between the two to get our point for our mesh. So we've actually lowered the height of this section of the mesh, of our terrain mesh. Now let's look at how we can modify some of these other values as well. Let's take this same float and range, minus 500 to 500, and let's use it in our starting point for our max y and our max x values. Let's also, for our second points, let's also use that for our position on those points as well. So here we're kind of varying the height at each of the corners of our mesh. Let's see how much this variance has changed it. So it doesn't look like we've changed too much of the curve in terms of the curve shape, but we are changing the heights of these corner positions based on where the heights of the curves themselves are landing. Let's return back to the Bezier train. Now, the real thing that will change the overall shape of the Bezier curve will be these tangent points. So right now we're setting each of them as 1000 and 1000 along the axes that are not our current direction. So our Y curves don't set any Y Bezier curves. So if we go to our map, we can actually click out, we can actually see our tangents if we click on these points themselves. So we have our tangent up here for our first curve. Now, if we move this, we can see how it'll affect the overall shape of the Bezier curve. We want it to stay on this flat plane along the curve. We don't want it coming in, so we're not stretching our train over itself. So we'll want one of the directions to remain at 0 or remain at the position along our current curve. And then we can change the height and distance of this curve to change the overall shape of the Bezier curve. So let's look in our Bezier train. Now from these thousands, let's go ahead and just use another random float and range. Let's just call it minus 1000 to 1000. And we'll just look at the resulting shapes from that, from adding in this randomization. And we'll go ahead and copy and paste that for each of our different tangent points. We'll need to make room on each of these since we're adding a lot more nodes. Here, then on our x's, we need to make sure we connect it to our y and z and leave our x alone. All right, there we go. So now we're modifying all of our tangents. And let's run this a couple times to see, look at the different shapes that we're generating here. We're getting some kind of different shapes in our curves. We're getting some variation now. Let's look at the curves themselves. So here we have our curve and the tangent points. But a lot of these we end up kind of averaging out a lot of our randomization, so our heights here, just get averaged based on how we're determining our vertex points by averaging our x and y curves. So what we can try to do is when we generate this y position, the y position for our y curve is generate this x curve position at the same exact height to make sure that we're at that correct position. And then later when we average them, they'll be at the same point, so our terrain will actually be higher here and more closely follow some of these curves. So let's look at our Bezier terrain. And here we'll have to look at a way to set our height values in our x components to match the height values of our y curves. In order to get these heights, we'll have to get rid of these random add-ins to our spline points. So I'll delete the 4 here for our 4 different points for our x curves. Now let's look at how we can get our z height from our y curve when our y curve is at the 0. The way we could do that is get our local curves, and here we'll have to get our first one. And that'll be our y equals 0 curve. And we can get our position along that curve. So here we could do get position or get location at time. And coordinate space will be world. And our time for this one would be our input x value. In this case, our x is 0. So we'll leave that as 0. And we can break our vector and get our random height that we got here. We could also connect our x and y's, but let's leave those unconnected now, as we want to only just grab our z value, our randomized height value, and our x and y should all be 0 anyway for this point. But then this allows us just make it a little clearer on what we're doing. We're modifying just the height value based on this other curve. Now let me copy and paste this below to our x max curve. Here we'll look at our maximum y curve, and we'll drag in our position, and our time at this one will be 1, as we are at our maximum x value. So we should be all the way down that curve. And I'll just leave these other 2 points as position 0 for now, and let's look at what this creates in our map. Matching our height here on this first position, but we're not matching our height at that far corner or these other positions. Yeah, actually, this will be our first curve again, but with the time of 1. This will be the end of the first curve. End of the first y equals 0 curve will be where our first max x curve starts. Let's go ahead and look at this. If we look at our curve, so along this edge, now we have our 2 positions starting at that same height, and at this end, the 2 positions at the same height. Now we'll need to do the same thing for this far side. So I'll copy our get location at time, and we'll move it farther down. We'll have to move everything down again. We can get this position, z height, for our second point now. And this will be for our second curve in our y curves at time 0. And then for our next curve, paste that in again. We'll get our y curve number 1 at time 1. Hit play, and let's look at our positions. So now all our corner positions are in the same exact spots. Perfect. Now from this position, you can go ahead and modify these different X's and Y's for the splines and these different height values based on what you want to get out of the terrain. So here you could modify your X's and Y's by larger values if you want larger peaks and valleys. So let's go ahead and just add another 0 in here to see what this looks like on these last two tangents. Let me open it in the full screen. So here we're sending our curve past the edge point because of the large tangent, which loops up then back to the corner point, and we're getting this like rolling feature. Now, if you had another terrain next to this that started from the same point, it could go over and leave you with a kind of cave. But there's also the chance that it would go down and kind of intersect itself. The terrain would intersect itself badly here. So in order to avoid things like that, we'd have to have rules of how large these tangents could be, but they would need to be based on the actual size of the mesh. So currently we're just setting a hard value for these different sizes. But let's increase the size of this mesh. Now these tangents are going to seem relatively very small compared to this very large mesh. So really there should be a way to modify the scale of the tangents based on the scale of the actual mesh. So you could come in here and we have our X scale and our Y scale, and you could multiply those into these random values to adjust the overall scale of the curves and their tangents based on the X and Y scale of the mesh itself. Let's adjust the height of the terrain to give us something a little more dynamic in terms of our heights changing. So here we have our minus 500 to 500. Create local variables from each of these. Call this first minimum one min random height. And this maximum one, we'll promote that to a local variable. That could be our max random height. For our min random height, let's set the default as minus 1000 and our max height as 1000. And now let's go copy and paste these through to our different random heights. Then our heights for the two X curves should not need these random heights since we're grabbing our height values from our Y curve data. So let's get more control over these random heights. Go back to our Bezier train. Let's set its scale back to 2000. Hit play. There we go. So now we're getting a bit more dynamicness in the overall changing of the heights in our curve. And here you can see we're getting quite different curves based on our large tangent changes as well. Now let's try one last modification here. Go ahead and edit these minimum and maximum tangent values. Now let's convert these to local variables. So this first one will be our min x tangent. And this will be our max x tangent. And our min z tangent. And our max z tangent. Now we'll need to bring these all these parameters into our other random ranges. We'll have to make sure that we connect our x's, z's, and y's appropriately. Here we'll connect these z's, but then we'll need to make our y local parameters. We'll name this as min y tangent and max y tangent. And we'll propagate those through. Great, now we can change each of these tangents separately. So if you wanted all of the z-based tangents to be greater or the y-based tangents to be greater, you can edit these all individually. So let's go ahead and just make our maximum y tangent very, very large. And there'll be some random chance whether or not we get that height, but let's just see what we get. So we're actually getting some very strange terrain since we're having with our large tangent, we're actually looping the mesh over itself. So you will want to have some rules on how exactly these tangents can scale based on the size of your mesh. But you could also, if you wanted to put a double-sided mesh on this and just use this as one single piece of terrain, you could do that too. It depends on like what your final use case will be. So let's go ahead, let's put a double-sided mesh on this just to see what it looks like. Let's see if we have one here in our level prototyping. Let's see if we can modify this current grid to be two-sided. So it'll give us a bit of an error since we're modifying this while the game's playing. Oh, there it goes. Got to compile the shaders. There. So if you're looking to create kind of like these different shapes like this, depending on what your use case is, you could, generate these very strange type terrains using very large values in these Bezier curves. But it's all up to what you want to do. So I hope this video gave you a good introduction of how to use Bezier curves to determine the bounds and the shape of our procedural terrain. Now you could go ahead and expand upon this in any way you want. You could also add in noise values on top of this and make this landscape be generated using seed values. And in a future video, I'll look at refactoring our code to make everything a little simpler and run a bit better and more easily modify some of these parameters. So I hope I'll see you in that next video. Otherwise, have fun making procedural terrain.